Okay, on the first packet, on the one titled covalent bonding, what you're going to have to do at the last part of it is how it draws dot diagrams. To do dot diagrams, first thing you're going to need is a copy of the periodic table, as in this one right here. We'll leave this one up on the screen for you at the end of it, so we can just use that. The things to remember, when we did, way back when we were drawing those circles and putting the dots on there for what the electrons are, if you'll remember, we could put on each one a certain number of electrons. So like in this first one, I could put 1, 2, right? And on this next one, I could put 8, and then I could put 18, and we'll keep going like that. And you have to remember how that works as we do these things. So every time you start a new row on the periodic table, you're going to go to a new energy level. Does everybody remember when we did that? Yeah? Okay. When y'all did that, and the drawings kind of came out like this thing that's about there it is. Like say argon right here was the biggest one we had. Argon. Okay. So you see how it worked out? We had first 2 went here, and then the next 8 went on the next ring, and then the last 8 went out here. What we were doing is trying to find out what our valence electrons are. Valence electrons are the electrons that are on the outermost ring, the outermost energy level. Everybody with me on that part? Mm-hmm. Now, we take that knowledge, and we use that to figure out our number of valence electrons on a quick and easy way now. All we have to do dot diagrams is figure out the number of valence electrons. So, first column is going to have 1. Second column, 2. Then we're going to skip this middle piece. Because they have like variable numbers. We skip that part. And we're going to go up to the next one that's 3, 4, 5, 6, 7. Got a guess on what this one is?
8.
8. Yeah. Alright, so we got 8 right there. Now, so, remembering that, we go into this piece. Define to write the dot diagram, this is what you're going to be doing on that page. You got to write the dot diagram, like say H. Where is H at? That's hydrogen, right?
Yes.
What column is it in?
1.
First column. First column means it's going to have 1 dot diagram, or 1 dot for the diagram. Boom, I just put a dot. That's it. Next one. Let's say we do aluminum. Where's aluminum at? Third column. So it's going to have 1, 2, 3 dots. Wow, this is hard. Everybody got this? All right, how about this one? Oxygen. 6th column. How many dots are you going to have? 6. Helium.
Oh, so that's something like that.
6? I don't know what that is. 6 dots. Dion? Where's that? 8th column. Next part is how to draw a covalent bond using those same dot diagrams. What you're going to want to do is show that relationship between the atoms, how they're merged together, how they're sharing the electrons. So, looking at our periodic table, let's say we want to do CH4. Should look familiar. It's number what? We want to do CH4. How many carbons are in that?
2.
How many carbons?
1.
1. 1 carbon. How many hydrogens?
4.
4. So, we draw our carbon in the middle. We're going to put our hydrogens around it. That's pretty easy, right? That's just showing me where they all are. The next thing I have to figure out is where are the dots going to go? Now, carbon, we just said a minute ago, is in this column, right there. So carbon's going to have how many dots?
4.
4. The trick to me, I've got 4 carbons and there's 4 hydrogens, right? So that tells me that it's going to share an electron probably with each and every one of those, right?
That's why I never put on the
Okay, so I'm sharing 1, but how many does hydrogen have? 1. One there, one there, one there, one there. Now, here's the trick. When I look at carbon, how many electrons do I see next to carbon? Wow, look at all these.
4. Oh, 6, 8.
How many electrons do I have by carbon?
8, 4.
8. All of them are next to carbon, right? What's happening is these things are sharing. Right here and right here. Those are being shared back and forth. Okay, so I can count that electron for both these. What happens if I were to draw 8 on that electron shell? Wouldn't that be full up, right? So I'll be filling it up. So now, carbon effectively has a full outer electron shell, which is what that element wants. They want to be full. What about hydrogen? Does it fill up with 8? How many does hydrogen take to fill up with? So on that first row, so it only takes 2. So these right here, that was enough for that hydrogen to be full, right? So boom, all we have to do is that, and there are, that will set up. Everybody with me so far?
Yeah.
Okay. Cl2. There's 2 of them though, right? Okay. So that means I'm going to have a Cl and a Cl. Right? What column is it in?
10.
Over there it's 7?
Yeah.
Okay. So it's going to have 1, 2, 3, 4, 5, 6, 7 on that one, right? The other one's going to have, how many? 7. 1, 2, 3, 4, 5, 6, 7.
So we go by column.
What about columns? So, do they each appear to have 8?
Oh.
Do they each appear to have 8 like that?
Yes.
Okay. Let's look at CO2. Okay. Carbon. Where is it at on there? What column? Fourth column. Let's put our carbon here. Oh, let's have a strawberry. Carbon, and we're going to have an oxygen. We're going to have an oxygen, right? Okay. I'm going to use a different color to set the thing straight. So carbon, I'm going to do their electrons in green. I've only got one place where I can share them back and forth, right? How many would say it has? 4?
4.
So 1, 2, 3, 4. Right? It's the only place it's got to share them. That's not enough for carbon, right? It needs how many? It needs altogether 8, right? It needs 8. Let's talk about how oxygen's going to work. How many does oxygen have?
6.
It has 6. So 1, 2, 3, 4. If I put them over here, if I put them over on that side, will that mean that they're being shared?
No.
No. But I can put them here. It's called they're being shared now, right?
Yeah.
How many does that mean that oxygen has altogether?
6. 8.
It's got 8, right? Because it's counting these. What that's called is a double bond. Okay? So I've got those, and I can do the same thing over here. 1, 2, 3, 4, 5, 6. Now, based on that, how many does carbon have now? That's all the carbons, right? So they're being shared back and forth, so carbon has 8. Good. The oxygen on both sides, how many is it going to have? It's got 8 there. This one's got 8 over here. So now, outer energy levels are filled on each one of those. Anybody have any questions? No? Okay. Y'all have your assignment going right now. You got that page. You got 2 other pages that's got, or 2 other packets got to be turned in by the end of class.